Hello friends, this video is an effort to introduce the basic concept of an operational single line diagram, also called SLD, of a substation. If you are an electrical engineer, student, or fresh engineer looking to quickly grasp the concept of SLDs, their switching and the interlocking in the substation, this video will be highly beneficial for you. So in this video, we will be covering the following topics: the switchgear, GIS switchgear equipment and their functions, GIS advantages over AIS, SLD terminologies, bay arrangements, disconnectors, also called isolators, earthing switches, CTs, VTs, bus bars, sub registers, and local control. So these things, these all components, these all equipments, I will be showing to you in the next slide through the single line diagram and through the actual real-time pictures. So the GIS advantage over AIS, you can imagine that before GIS, our substations were AIS. So this requires a lot of land area, which was not possible in urban areas because there is space constraint. So GISs are GISs are compact in size. They are reliable. Enclosed design prevents contamination and reduce faults. It needs low maintenance because SF6 gas is used as a arc quenching medium and also the insulation medium. This reduces the tear and wear, extending the equipment life. And the safety is enhanced more than the AIS. So let us go to the next slides where we will be discussing the actual system. As I told you in the starting of the video that we will be discussing the operational single diagram of standard substations. So here I have taken the part of a substation which is just showing the 110 kV side. Basically this substation is having two voltage levels, HV and medium voltage, and with the transformers. So this voltage is stepped down from 110 kV to 13.8 or 11 kV depending on the standards of the country where the substation is being constructed. Single line diagram is a main document to understand the substation and its configuration. This is a gas insulated substation where the arc quenching medium is, or insulation medium is, SF6 gas. Due to the SF6 gas invention, the size of the substations have been reduced much and become more economical, maintenance free and fault free. Nowadays 90% of the substations are GIS type. Before that it was AIS. Difference between AIS and GIS is the insulation medium. AIS substations needs more areas, while roughly you can say 4 to 5 times more than the GIS substation of the same level. Now in this single line diagram, you can see on the top there are 6 incoming feeders, and in downside there are 3 transformer feeders. So these incoming feeders basically can be used as the outgoing feeders as well. So combinedly we call it a feeder which can receive power or which can transmit power from the outside, and vice versa. So let us understand one typical feeder which is also called a bay. So one bay is actually having one breaker. The main equipment of a bay is a one breaker. The number of breakers and the number of bays are in most of the case same. So here you can say that this single line diagram has 6 plus 3 plus 3, 12 bays, 6 line feeders, 3 transformer feeders, 2 bus couplers and 1 bus section. Let us see which one is the line feeder. I will highlight here by the cursor. This is a spare. This is the name of the feeder and this is the designation of the feeder, E07. Similarly, E05 is another feeder. E03 is the transformer feeder. It is shown downside for easy identification and for clarity, but actually in GIS all are on the same sides. Similarly, this is the bus coupler A, bus coupler B and bus section. The functionality of bus coupler and bus section is the usage of this one is to maintain the substation, load requirement, maintenance conditions, shifting the loads, meeting the emergencies. Most of the time, these bus sections and bus couplers provide a facility to get the power from alternate sources. So let us focus on one bay to understand its component, and all other bays will be of more or less same. So our journey of power in the substation starts from, okay guys, so now the power starts from here by the cables. Normally in GIS we are inserting XLP cables which are of size of 630 mm square to 2000 mm square XLP power cables, and these are high voltage underground cables. So they feed the power at this point. Here in some substations there are some surge arresters on the GIS, but here in this station specifically there is no surge arrestor, but the first point of entry of power is at the surge arrestor. Surge arrestor is used to arrest any surges from the network to protect this equipment. Transients, switching transients can cause huge energy and damage the expensive equipment. So a small surge arresters or the suitable surge arresters are used here to suppress that energy, block that energy which is not desired to be flown in this direction. Here comes a high-speed earthing switch. It is called high-speed earthing switch because it's close with the more speed than the normal earthing switches. This earthing switch is used when there is no power on the line. You can close it to protect the line. Then VT, voltage transformer. The purpose of VT is to measure the voltages, high voltages, because 132 or 110 kV voltage cannot be measured directly through the voltmeters. Voltmeters only measure the low voltages like 110 to 20 volts. But here it is 132 kV. There is no any meter to measure this voltage. So to scale it down in a proportionate way, these VTs are designed. These three-phase VTs will take input of 132 kV or 110 kV volt and step down the voltage to typically measurable voltages of 100 volts. Then these are faded to control and protection and metering. This is a separate field and we will discuss in details in some few videos, hopefully. Then there's the line isolator. Line isolator actually provide the facility to be ready for the energization, okay, and it will give you an option to isolate the bay from the line or to connect the bay with the line. Before closing the breaker, This Q9 has to be closed. This is called Q9 because there are some standard designations. I will tell you. This disconnector is Q1. This is Q2. Q1 for bus bar 1, Q2 for bus bar 2. Q9 is line isolators, and Q8 we call it high speed earthing switch. These are the standards being followed in the Gulf countries, but not necessarily to be followed in every country. But if you are preparing for interview for Gulf countries, so these terminologies will give you the confidence, and the interviewer will think that you have the know-how about the standards there. Let us continue. This from P1 to P2 are the CTs. Same way like VT, this CT is also a step down transformer for current. This is called current transformer or instrument transformer, which will step down the current in a measurable range. So normally, for example, the current here, the circuit breaker is designed for 1600 ampere. Suppose the current flowing here 1000 ampere or 700 amperes. So no one can measure this current, but this CT will step down it in a measurable value. There the disconnector Q1 and Q2. Before closing the breaker, you have to be sure that which bus bar you want to connect with this way. Accordingly, you have to close that disconnector. If you close this Q1, it will energize this bus. If you will close this disconnector, it will energize this. Both of them cannot be closed together under normal conditions. But in maintenance conditions or in some special conditions, you can do it. However, once your prerequisites for circuit breakers are met according to the interlocking scheme, you can easily close the circuit breaker. Same philosophy will be followed for all other bays. Now reading the bus bar. This is a 110 kV bus bar. Nominal voltage is 145 kV. 110 kV is operational nominal, and 145 can be operated up to that. And the 3-phase 40 kiloampere is short circuit level for 1 second, means this bus bar can withstand a short circuit current of 40 kiloampere for 1 second. 60 Hz the operation of the system frequency. In some countries it is 50 Hz, and this is the current rating 850 degrees centigrade, depending upon the environment and the requirement of the project. So these GIS are especially designed for that area and under that temperature. So every customized design options are available with the GIS manufacturers. They can deliver in any environmental conditions. They will design specifically for that area. There are some VTs in the bus bar. So the purpose of this VT and this VT, you can use it for the synchronizing purpose, and also from this side you can use it for the synchronizing purpose. All other things are typical for bus section and bus coupler. Let me tell you briefly their purpose. During the maintenance period or during the load shedding or during load management, these bus couplers and bus sections are being used according to the load requirements. So this setup gives the operational and maintenance team flexibility to shift the loads, to manage the loads under normal or abnormal conditions. So guys, this is the brief introduction of single line diagram. These are the legends which are used in complete single line diagram, but now only showing the 110 kV GIS. That's why we only covered few, but in next phase we will cover the other side of the single line diagram. If you like it this video and you found it informative, please subscribe and follow for the next video. We will try to cover up the complete equipment of the substation, their functionality, their design review, their design cycle, planning, construction, and testing and commissioning. It will be beneficial for the project managers, project engineers, and site engineers. We will touch the civil construction also. So stay tuned, keep in touch. Thank you very much.